Hello my dear friends, in our last video we have discussed and derived an equation for electric conductivity by using the principles of classical theory of free electrons, right? And it is a theory which was proposed by Lorentz and Drude in the year 1900. But though we have derived an equation for the conductivity, but it has failed in explaining few things, and those few things in which it has failed were the drawbacks of that particular theory. And what were the drawbacks? Let us go to the next page. And yesterday we have derived an equation, right? And the equation is sigma equals to n e square lambda by root over 3m kbt. So from this equation, if we see it deeply, it also failed in explaining the specific heat capacity of electrons. Electrons do possess some specific heat, but it failed to explain the correct value of specific heat that electrons are having. And also from this equation, if you see closely, and it gives the direct relation between the electron concentration N and the electric conductivity sigma. But there is no direct relation between the electron concentration and electric conductivity. But the theory is explaining, has driven an equation which is giving the direct relation between the two. If all the other terms, if all these terms are constant, it tells us sigma is directly proportional to n. If n increases, there is an increase in sigma also. But there is no direct relation in such a way. So it failed in explaining the relation between the concentration of electrons and the conductivity of electricity. And if you look into again, so it is giving a relation like if all the other terms are staying constant, if n, e, lambda and mass of the electron kb, if all these terms are constant, it is telling that it is inversely proportional to root t, which is not true at all. But experimentally, if you do experiments, the relation is correct, but the relation is like this. It is not sigma inversely proportional to root t, it is sigma inversely proportional to, wait a second. It is sigma inversely proportional to t directly. Correct? So if you look into this formula, so many flaws and mistakes were there, which are experimentally proven wrong, but theoretically they were correct, as we have proved it yesterday. But later, this is the theory. Classical free electron theory was the theory proposed by Lorentz and Drude in the year 1900. But later, in order to take out some modifications, in order to overcome the drawbacks in this theory, Sommerfeld was the scientist who proposed this theory to overcome all the drawbacks in classical theory of free electrons. So Sommerfeld came out with the principles of quantum mechanics. By using quantum mechanics, he solved the drawbacks which were taken place in classical free electron theory. Clear? In yesterday's video, we have derived an equation for electric conductivity by using classical mechanics principle. But in this video, we are going to replace all the classical mechanics terms with the quantum mechanics terms, right? In classical mechanics, the mass of the electron is treated as constant. So that is the reason it is taken out from the derivation. It is put as a constant. It is treated as constant at everywhere, wherever it is used. Right? But in quantum mechanics, mass of the electron is not treated as constant every place. It keeps changing. And this changing mass of the electron can also be called as effective mass of electron. What is that? Effective mass of electron. Effective mass of electron, which is represented by letter m star. It is represented with m star. So this m star is nothing but it is the effective mass of electron, that mass which keeps changing throughout, right? And this quantum mechanics, this quantum free electron theory is having some assumptions which are called postulates. So we are going to discuss the postulates at the last. But first of all, let us go with the derivation. Let us go and derive the equation for the electric conductivity by using the principles of quantum mechanics, right? So here mass is not treated as a constant. Remember this point. Mass is not treated as constant. It keeps changing, so that it is called as effective mass of electron, right? We already know one thing, that for a conductor there will be so many electrons which were moving in all different directions and possible directions when there is no electric field is given. But the moment when the electric field is given to the conductor, all the electrons will take a unique direction and travel in a single direction, right, which is opposite to the electric field given. So the electrons must have some force to travel in opposite to the electric field, and that force can be written as, wait a second, I will take a new page. Here the force can be written as F equals to minus E into E. Here small e is the charge of the electron and capital E is the electric field given to the conductor. Since both of them were traveling opposite in direction to each other, minus symbol is there. So that minus symbol indicates both of the electric field and electric charge are traveling in opposite to each other, right? But according to Newton's second law, F equals to ma, where a is the acceleration, which is the rate of change of velocity with respect to time. So m into dv by dt. It is rate of change of velocity with respect to time, right? So both the equations are equals to F. So when I start comparing these both equations, minus E into E equals to m into dv by dt. I already told you that here mass of the electron will not remain constant. It keeps changing. Since it is not constant, it is a variable. It must be included in the derivation. It can be differentiated. Only constants cannot be differentiated. There will be no change in constant. But in variable, there can be a change. So minus E into E equals to, mass is not a constant. It is treated as a variable. It can change. So any change in particle can be differentiated. So d into the bracket m into v divided by dt. I have taken that m inside the derivation and it became product with the velocity. So it is the derivation of mass into velocity with respect to time. And what is mass into velocity? It is momentum represented with the letter p. So minus E into E equals to d into p by, it is capital P, okay, capital P divided by dt. So I just wanted to take out dp alone. So it becomes minus E into capital E into dt. Consider this equation as equation 1. Take out next page. Yes, we have already studied that according to Broglie. Let us first write this equation 1 to a corner of our page. Let us minimize this equation, or let us copy this equation, paste it in the next page. Yes, and I will minimize it and I will put it here. Let us write all the equations here for our convenience. So we already know this thing. According to de Broglie wavelength of a particle can be given as lambda equals to, I will change the color, lambda equals to h by p, where h is the Planck's constant and p is momentum. So p can be written as mv, right? Initially it is mv, later on it can be p, but lambda is equals to h by p. So p becomes h by lambda. So on multiplying and dividing with 2 pi on RHS side, so I have multiplied it with 2 pi and dividing it with 2 pi. So the equation changes into h by 2 pi and 2 pi by lambda, right? So p equals to, h by 2 pi can be written as h cross and 2 pi by lambda can be written as k. Here k is the wave vector, right? It is the wave vector. So when I start deriving it, differentiating it on both sides, dp equals to, so h cross, what is h cross? It is h by 2 pi. H is a Planck's constant and 2 pi, it is of course a constant. So the whole term can be, this whole term can be a constant term. So h cross is also constant. So it cannot be differentiated. So it is taken out as constant. So it is left aside, and k, inside k, lambda is there. It keeps changing. 2 pi may not be changed. It is a constant value. But lambda can be changed. Since lambda can be varied, it is the wavelength. So it can be differentiated. So d k. dp is equals to h cross dk. Consider this equation as equation 2. Also write this equation here. dp equals to h cross dk. And let the above equation, which is p is equals to hk, or else consider this equation as equation 2 and consider this equation as equation 3. Right? Let us make a change. Consider this equation as equation 3. Let us change the number. It is 3. Equation 3. Right? And p is equals to h cross k can be treated as equation number 2. Let us also write this equation. P is equals to h cross k. Right? So let us also compare these two equations. See, here dp equals to minus small e into capital E into dt. It is equation 1. And equation 3 is dp is equals to h cross dk. Right? And this equation is equation number 2. Okay? So when comparing these two equations, what happens is that minus e into capital E into dt equals to h cross dk. And I just wanted to get this term dk. So what happens? dk equals to minus e into dt divided by h cross. Let us write this, divided by h cross. So take this equation as equation 4. As equation 4. Let us try to minimize this equation again. And put this here. Right? Now, from second equation, equation 2, from equation 2, P equals to h cross k. What is P? It is the momentum. So it can be defined as product of mass into velocity. Mass. And what is this mass? Is it direct mass or it is the effective mass of electron? It is the effective mass of electron which keeps changing, which is not constant, right? So it is represented with m star. M star into velocity equals to h cross k. I just need velocity. In yesterday's video, while deriving the derivation for electric conductivity using classical mechanics, we have first found out the drift velocity. Here, velocity is not called as drift velocity. It is the increment velocity, right? Increment velocity. So we have found out the relation between drift velocity and electric current density. Later on, we have moved to electric conductivity. In the same way we are doing here. So here I want this velocity individually. So this is what I am going to do. V equals to h cross k divided with m star. So when I start differentiating on both sides, what happens is, let us erase this all and take this term. So I just wanted to differentiate this term on both sides. dV equals to h cross by m star multiplied with dk. And here we have found out from equation 4, you can clearly see dk equals to minus e into dt by h cross. So this is what we are going to replace with. So we are going to replace this dk with this term. So let us do it here itself. So I am removing dk and replacing it with dk equals to minus E into capital E into dt by h cross. So you can see here on the numerator one h cross is there, on denominator one h cross is there, both can be cancelled. So these both can be cancelled. So dv equals to minus E into capital E into dt divided with m star divided by m star. Now let us do some modifications. So what I'm gonna do is that, wait a second. So from this equation, for this equation, let us try to write dv as delta v and dt as tau. Tau is the relaxation time. So minus E into capital E into tau divided by m star. So delta V became minus A into capital E into tau by m star. And now what happens? We have to find the relation between the electric concentration or the electric density, electron density, and the velocity. In classical mechanics, it is drift velocity, but here it is increment velocity, which keeps changing. Right? So we already know the relation between the electron density and the velocity, that is J equals to minus N E Vd. It is in classical mechanics, but here it is delta V. Right? Here it is delta V. Let us go and replace it. So take this term, J is equals to minus Ne Vd, Ne delta V. So J can be written as minus N E. What is delta V? This is delta V. So let us try to. So again it can be minus E into capital E into tau divided by m star. What happens? Let us go to Nopes and here. Okay, fine. See here what happens is that, let us try to simplify it. So J equals to minus into minus, it becomes plus, and N into E square into tau by m star. Right? Now we have found the relation between the electron density and the increment velocity. Thereon we have found the expression for electron density in terms of electron charge, electron concentration, and the relaxation time and effective mass of electron. And we also know another relation, like according to Ohm's law, conductance equals to the electron density divided by the electric field, divided by the unit electric field. So here on we can get J equals to sigma into E. So let us start comparing these two equations, right? So what happens is that, so I will write it somewhere here. I will write it here. N is square tau by, here we have forgot to write E, and it's got tau into E divided by m star equals to sigma into E. Sigma is nothing but the electric conductivity. Here on the numerators we are having E, so those both can be cancelled out. So the final equation comes out to be, let us wrap this all. Right. So final equation comes out to be like this. N is square tau, there is no E, it is cancelled, divided by m equals to sigma, it is m star. And this is the final equation. So sigma is equals to N E square tau by m star. This is the final equation for the electric conductivity through quantum free electron theory. Right? Hope you have understood this derivation, and go back to the video if you do not understand at any point. So go back to the video. Let us pause the video for some time. Try to understand the topics which were on the screen. Right? If you don't understand, please text me or ping me so that I could respond immediately, and I will try to clear your doubts. So now on the screen you can see some assumptions made in quantum free electron theory, and this can also be called as postulates of quantum free electron theory. So on the screen you can clearly see that on the screen you can see the assumptions made. So let us track this. Right. So these are the main assumptions. Made in quantum free electron theory. The energy of the free electron is quantized. What is meant by quantization? So in America, the currency or the dollars are quantized, and penny is the quantum. Penny can be treated as the least, and here in our India it can be 1 rupee coin. So there are levels for this currency, right? And quantum, it is nothing but it is the invisible unit of matter, right? It is the invisible unit of matter, and all those can be the plural form of quantum is quanta. If quanta is all together taken at one place, it can somehow build a block. So it can be a building block of matter, maybe, right? So energy of the free electrons is quantized. So the electron's energy is not stable, it can change, right? It can change, it keeps changing. So it is in ascending order. It will be at very low energy levels while at very less temperatures. If the temperature starts increasing, the energy may also can increase, right? So the distribution of the electrons among the various permitted energy levels is per the Pauli's exclusion principle. So by using this Pauli's exclusion principle, the distribution of electrons among the various energy levels. So there will be so many energy levels in the atom. So to that energy levels, it uses Pauli's exclusion principle to distribute the electrons according to their energy levels, right? According to the energy levels, electrons will be distributed with the help of Pauli's exclusion principle. So at the third point, you can clearly see electrons travel under a constant potential inside the metal. However, in a conductor, if you take in a conductor, there will be electrons moving in all random directions. But the only energy that electrons will have is that kinetic energy, and there will be no potential energy. So the potential energy in the metal is zero, right? The potential energy in the metal is zero, and they will be confined to the boundaries. Like for example, if I take this as the conductor, for example, this is the conductor, this red rectangular diagram, and the electrons inside the rectangular diagram can go nowhere. They must stay inside, and they should not exceed the limit of the boundaries. They should not get out like this. They cannot come outside like this. So this is the thing which tells us the electrons are confined to the boundaries of the metal, right? And next point, the attraction between the lattice ions and the electrons, as well as the repulsions between the electrons, are neglected. In the classical free electron theory, we have studied one thing. So there will be some collisions taken place, right? And here in this quantum theory, the repulsions are neglected. The repulsions between electron to proton or positive ion core, or the repulsions between electron to neutral electron, right? And there are some successful terms which are merits of this theory. It defined the specific heat behavior of the metal, where the classical free electron theory failed to explain the specific heat behavior of the metal, right? And coming to the second point, and it also successfully explained the dependence of electric conductivity on electron concentration. See here, you can see the relation between sigma, which is the electric conductivity, and N, it is the electron concentration. Here, the relation between these two has become valid. So it explained in such a way. And the fourth point, it explains the electrical and thermal conductivities of the metal, right? It explains the electrical and thermal conductivities of the metal. And the fifth point, it explains the then ionic emission. Therm ionic emission. So how the ions are being emitted when it is heated. So these are the things it is successful in. So it also successful in explaining the temperature dependence of electrical conductivity. Right? It's right. So finally, we can conclude it by saying it has overcome all the drawbacks which were taken place in classical free electron theory. In classical free electron theory, it failed in few areas, and in quantum free electron theory, Sommerfeld was successful in explaining the drawbacks. He modified all the drawbacks in classical free electron theory. So from this video, I hope that you could understand a bit of these theories of electrons, theories of free electrons, and you can also differentiate between these two theories, right? Hope this has helped you. Thank you so much.